So let us solve this problem. We got to prove that that is integral 0 to infinity e to the power of minus x square dx is half of gamma function, which is 1 by 2. And we are got to show that gamma 1 by 2 is root pi. Okay. And okay, so we know that gamma n is equal to integral 0 to infinity e to the power of minus t to the power of n minus 1 dt. Okay, this is the gamma function. Now let us put n is equal to half. Okay, so on the left hand side you have gamma half, which is equal to integral 0 to infinity. Now this will be e to the power of minus t. Now this is t to the power of minus half. Okay, dt. Now let us consider t as x square. So dt will be 2x dx. Okay, when this is for t is equal to 0 to infinity. So when t is 0, x is 0, and when t is infinity, x is infinity. Yeah. And now let us proceed further. Okay, now let us substitute t as x square, dt as 2x dx. Okay, and also the limits. So this would be gamma half integral 0 to infinity. This is x being 0 to infinity, e to the power of minus x square. This is 1 by x, 2x dx. Okay, which would be after simplification. So this is 2 integral 0 to infinity e to the power of minus x square dx. Okay, this is gamma half. Now this is equal to half of gamma half. Which is 0 to infinity e to the power of minus x square dx. Now let us change the variable x to y. Okay, by changing x to y, we have gamma half, which is equal to 2 times integral 0 to infinity e to the power of minus y square dy. So x to y dx to dy. So x to 0, y to 0, and x to infinity, and y to infinity. That's what. Okay. Now let us take both the results. Okay. So gamma half multiplied gamma half, which is equal to 2 times integral 0 to infinity e to the power of minus x square dx multiplied to e 0 to infinity e to the power of minus y square dy. Okay, and that would be equal to 4 y 0 to infinity integral x 0 to infinity e to the power of minus x square e to the power of minus y square dx dy. Now, this is by the property of multiple integrals, or can write as gamma half whole square as 4 times y 0 to infinity x 0 to infinity e to the power of minus x square plus y square into dx dy. Okay. Now, let us, the region of the integration, which is in the first quadrant, um, let us change to polar coordinates by putting x as r cos theta, y as r sin theta. So dx is equal to and dr. Let us put dx and dy together, which is equal to dr into r dA theta. Okay, and now r varies from 0 to infinity, while theta varies from 0 to pi by 2. Okay, so let us substitute gamma half whole square, which is equal to 4 times integral. Now this is for theta 0 to pi by 2 and r 0 to infinity e to the power of minus r square r dr d theta. Okay, can separate it for integral theta 0 to pi by 2 d theta multiplied r is equal to 0 to infinity e to the power of minus r square r dr. So this is 4 integral theta 0 to pi by 2 d theta. This is minus half e to the power of minus r square and r being 0 to infinity. Yeah. Let us substitute 4 integral 0 to pi by 2. This is d theta. Now this will be minus, okay, e to the power of minus infinity minus 1, okay, d theta. Yeah. Or which is equal to, after simplification, this will be 2 times integral theta 0 to pi by 2 d theta, which is equal to pi, or gamma half is root pi. Okay, hence we have shown that. So let us show that gamma n is equal to 2 times integral 0 to infinity e to the power of minus x square x to the power of n minus 1 to n minus 1 into dx. Okay, again, we know gamma function definition, that is gamma n is equal to integral 0 to infinity e to the power of minus x x to the power of n minus 1 dx, right? So let us put x as t square. Okay, so dx is equal to 2t dt. So when x is 0, t is 0, and x is infinity, t is also infinity. So gamma n will be integral 0 to infinity e to the power of, this is t, minus t square n minus 1 2t dt, or 2 times 0 to infinity e to the power of minus t square t to the power of 2n minus 1 dt. Okay, let us change t to x. Okay, so gamma n will be 2 times 0 to infinity e to the power of minus x square x to n minus 1 dx. Okay, now let us evaluate integral 0 to infinity x to the power of m e to the power of minus a x to the power of n dx. Now let us put a into x to the power of n as t. Okay, so this is a n into x to the power of n minus 1 dx is equal to dt. So when x is equal to 0, t is 0, and then when x is infinity, t is also infinity. So this is x is t by a, t 1 by n. Okay, so dx will be dt by a into n x to the power of n minus 1, or dt by a n is equal to a by t to the power of n minus 1 by n. So let us substitute this. Now this is, which is equal to 1 by a n integral 0 to infinity t by a to the power of m by n e to the power of minus t e to the power of n minus 1 by n divided by t to the power of n minus 1 by n into dt. Okay, and then this would be 1 by n into e to the power of m plus 1 divided by n integral 0 to infinity e to the power minus t to the power of m plus 1 divided by n minus 1 into dt. Or 1 by n into e to the power of m plus 1 divided by n gamma function. m plus 1 by n. Okay, provided this is greater than 0. Now let us prove this. Okay. Now consider log of x to the base e as minus t, so that x will be e to the power of minus t. So dx will be e to the power of minus t into dt. This is minus. When x is 0, t is 0. When x is 1, t is equal to 0. So now let us substitute, which is equal to t. This is infinity. Good. T is infinity. Okay. T is infinity to 0, e to the power of minus t to the power of m minus t to the power of n minus e to the power of minus t dt. Okay, which is equal to minus 1 to the power of n integral 0 to infinity e to the power of minus of m plus 1 into t to the power of n dt. Okay, and then which is equal to minus 1 to the power of n integral 0 to infinity e to the power of minus m plus 1 into t to the power of n plus 1 minus 1 dt. Okay. Now, which is equal to minus 1 to the power of n comma n plus 1 divided by m plus 1 to the power of n plus 1, which is equal to minus 1 to the power of n into n factorial divided by m plus 1 to the power of n plus 1. Okay, so hence we have proved it. Yeah, thank you.